Just give me a moment. I'm connecting my headphones and then we will continue. Okay, again, mic check. I'm audible. Can anyone please speak as well so that I can check my speakers? Anyone please unmute and speak something?
Yes, sir, you are audible, sir.
Okay, thank you. I can also hear you. A warm welcome to all of you to this 6 weeks internship program on embedded systems in IoT. And first, we are going to cover the content of embedded systems, and then we'll go further for IoT part. So I'm Ashok Kumar, and I'm the founding director of Ensino Research and Development Private Limited. Overall, I have experience of 12 plus years in the same field, and also I have experience related to automation engineer and GB Springs and Private Limited industry, which is basically working in the field of Indian Railways. They are they are the manufacturers of many springs for Indian Railways. So I have experience of that company as well. And after that, I included myself in this training and internship and research part. So I do have research papers and patents in the field of IoT, agriculture, and medical fields. So congratulations to all of you for being here. And now we are not going to just connect for a day. We will be connecting each other with this content for next 4 to 6 weeks. And I hope you all have the content which we are going to cover here. If you don't have, you can ask. We will share that on the group. Also, we will share the study material and other required things which may required during this internship. Also, I would like to let you know that we have many candidates in this session from different states. Almost 40 candidates we have in this batch. I don't know why only few candidates have joined anyways, but we have to continue. So we have from different states. So I'll be continuing this session in English only. And if anyone like have any issues with the what to say like pronunciation or accent, I'll speak slowly so that everyone can understand whatever I'm saying. And sometimes it may happen like you're not getting me. You can raise your hand. You can ask whatever your questions have. And other than that, if someone want to ask any question, they can also raise their hands. And I'm comfortable with Hindi and English both. So you can ask your question in English as well as in Hindi, right? So it's up to you in which language you want to talk with me. I don't have any problem. It's just that we have to be confident in the topic which we are going to cover here, right? So let's come back to the main point of this 6 week internship program, which is IoT followed by embedded systems. Can anyone from you guys will give me a small idea about like what is embedded system? You can unmute and start speaking. There is no problem. No one is going to give me idea about what is embedded system. Okay, fine. And are you all from engineering background or someone is from any other background as well? Because embedded systems somehow cover the content of electronics. So electronics or let's say physics, right? So we must have idea about the things related to hardware, the things related to electronics, the things related to physics. So if we have that much idea, we can complete it smoothly. Whatever are the things I'll cover from very basic. I'm not asking you to tell me each and everything related to your topic. I know how I have to start this session, how much depth knowledge you have. So I'll be taking this session from very basic, so we not need to worry about. But still, if I'm asking something, I want some inputs from your side. And what is the reason behind that? Because it creates a healthy conversation. Like if you are not going to speak and only I am speaking throughout the session, it will be a kind of lecture for me. And if you also speak, I'm also speaking, that means we are interacting with each other. And if we are interacting, that means we are learning in a good way. So I don't want to make it a lecture like your academics, like your college lectures. So let's make it a fun. Let's make it a smart learning. So you also have to speak a lot during the session. Okay. Whatever I ask, you have to answer those things. So I got few reviews. Integration of hardware and software to build a specific application is called embedded systems. Yes, you are absolutely fine. We can also say that the combination of hardware and software is called embedded system. The combination of hardware and software is called embedded system. Embedded system, for we have few applications of embedded systems, like Aman mentioned here, the use which we use for robotics. This is electronic device which used for robotics. Correct? You are also right. So embedded system is basically a device. Embedded system is basically a hardware which we also use in many robotic applications with customized programs, which is called software. So at last, we have one very simple definition, the integration of hardware and software. To build a specific application or to build a specific task is called embedded systems. Correct. Now in embedded, we have many tools, many controllers, many technologies available. So we have to find out the best one for us. We have to find out the best one in the field of IoT so that we can conclude this 6 weeks internship followed by a project very smoothly. But before we start selecting which controller to use or which components or which tools or which technologies to use, first we also need to understand what is the need of embedded system. What is the need of embedded system? So as we simply said, the combination of hardware as well as software is called embedded system. And here the hardware we use to perform specific task, to perform any specific application. Now, what kind of applications that may be? That may be like doing kind of automations. So mainly, if we talk about embedded system, we use them for the purpose of automation. So let me share my screen and then we will continue this session. Right. So what we were discussing about applications, the need of embedded system. So the basic need is automation. The basic need is automation. Now, why we do automation? First of all, the automation means any process which we want to make automatic is called automation. The any process which is automatic, which we want to make automatic is called automation. Now, the need of automation is simply related to human being. We guys are so lazy. We don't want to do our works by ourselves. And for each and every single task, we are dependent upon machines or we are dependent upon others. That's why we need automation. In technical terms, we can say to reduce the human efforts. To reduce the human efforts, we use automation. If we start reducing the human efforts, that means we are reducing the manpower. Guys, see, I'll share the study material, but still, I want you guys to note down whatever is important for you. It's not mandatory to note down each and everything, but if you want to note down, like it's completely your choice because it will definitely help you in near future during your placements, during interviews, and during the project work as well. Whenever we will be doing this project or whenever you will be doing your final year projects, that time you may need this, right? So if we start reducing the human efforts, that means ultimately we are reducing the manpower. And in the same way, we are reducing the labor cost. And then next, if we start using automation, definitely we are onto the right track to enhance productivity of our plant, to enhance the productivity of any industry. For an example, suppose I am working as a lineman in any bottle filling plant. Suppose I am working in as a lineman in bottle filling plant, and my task is to fill the water bottles. And they have given me a target, like my supervisor has given me a target to fill at least 100 bottles a day. 100 bottles a day, right? So that particular industry is dependent upon me or any other labors there. Now, what happened? The very first day when I started working on the target of filling 100 bottles a day, I did it well, no problem. Next day, it was fine. Third day, when the task was same and I have to repeat the same task every time, I started getting bored. And when I get bored of, I started giving a many excuses of not completing my task. That means next day when I'm getting bored, I just fill 90 bottles. Next day, 80 bottles, 70 bottles. And this way, the production is decreasing slowly. And this was the only one reason I just told you. There may be many reasons, like one day I don't want to go because I have fever. One day I don't want to go office because uh, I'm not in mood. One day I have to go somewhere out with my friends. One day I have family functions. One day I have another excuse, dating with someone and all. So this mean we have a lot of excuses, and the industry has to depend upon us. And this is the reason why we need automation, because machine don't have excuses. They never get bored of, they never get tired. Whatever task you assign, they have to complete it by the time. So if you say you have to product 100 bottles a day, if in summer's time you say you have to product 100, not 100, 1,000 bottles a day, it can do that work as well. So that's why we need automation, because machines don't have excuses like we humans. So this was also the strongest point why we do automation. So I told you three major points. The first one, to reduce the human efforts, that means to reduce the manpower. Second one, if we start reducing the manpower, we are reducing the labor cost. The third point, to enhance the productivity. In the same way, the fourth point can be to improve the quality of the product. My supervisor gave me the task to fill 100 bottles a day. And suppose I'm completing my target continuously. Now, they just don't want me to fill the bottles. They also want the quality. And now quality in which terms? Quantity. Every bottle. Suppose I'll show you a bottle. Suppose I have a bottle, right? And we have to fill, this is because of background. Okay. So we know that we see that all the bottles are filled this much. And this space is almost empty every time. In every bottle, like when we talk about water bottles, cold drink bottles, alcohol bottles, or any other bottle, we see around this much space in every bottle, right? Now, let's assume we have to fill this bottle 80%. This is the mark for 80%, right? Now, when manually I start filling these bottles, I'm very sure, because we are not supercomputers. So it may happen the first bottle I'm filling 80%, the next bottle I'm filling 81%, and the next bottle I'm filling 79%. And this way, the quality is compromising. Now, when we ask the machine to fill those bottles equally, 80%, they will fill each bottle 80%. So that's how automation works. Now, further, if we see, we can divide this automation into three different categories. The first category, I'll note it down somewhere. So let me open the text document. I'll share these things with you guys. Whatever I'll be noting here, I'll share that thing in the group. Okay, I'm also added in that group. If you have seen, I just posted join meeting of message just 5 to 10 minutes ago. This. So whatever I'll be writing, I'll give you. You just have to understand what I am saying. And the things which I am not writing up here, you have to note down if you want to. So automation has three different categories. The first one is called soft wire automation. Soft wire automation. And second one is called hard wired automation. And the third one is called industrial automation. Soft wire automation. That does not mean which has the soft wire which can be turned around. No. Soft wire mean it's not software, okay? It's soft wire. Soft wire mean flexible automation. The kind of automation which we can move from one place to other very easily. We can move any device without loss of wire, without loss of device. Is called flexible or soft wire automation. We have many appliances at our home, and I can count all of them in this category. For example, washing machine, refrigerator, induction, microwave oven. So these things, like, we have to simply plug it out and move it somewhere, plug in again, plug out, move, and plug in again, and it's working. So that kind of automation is called software automation. So if we say that a washing machine, if we say an induction, this is also a kind of automation based on embedded systems technology, right? Then the second one is hardwired automation, which is also known as fixed wired automation. So the kind of automation where the wiring part is fixed or mounted under the wall, are known as hardwired or fixed wired automation. Generally, we see these kind of automations in public places. If I'll give you a few examples, then elevators, lifts, escalators, automatic door locking systems, which we generally see like in malls or offices, hospitals. So those are known as fixed wired, hardwired automation. So I'm mentioning the applications are office appliances, and these automations are also based on the tool embedded system. So this is also embedded system, and this is also embedded system. Then third is industrial automation or factory automation. So the kind of automation which we generally see in plants, industries, factories are known as factory automation or industrial automation. For example, suppose if you have to control the motors, you have to control the conveyor belts, or suppose you have to control the valve, or you have to control the boilers, contractors, actuators, and any load. Those are known as industrial automation. And for this category, we have another tool called PLC and SCADA. So like embedded system is the combination of hardware and software. In the same way, PLC is also the combination of hardware and software. And SCADA here is completely software part. SCADA here is completely software part, which we use to create animations related to industries. And further, once those animations are developed, we use them for monitoring and controlling purposes of industry. SCADA is basically supervisory control and data acquisition. Supervisory control where only one supervisor can control the whole plant, can monitor the whole plant. And data acquisition. Data acquisition here mean collection of database. That mean if we want to collect the data of different machines, different transducers, different sensors, or different sensing elements, we can collect all of them at one place, which is called SCADA. So we need a PC, desktop, workstation, or a laptop to install SCADA software, and which we need to interface with PLC so that we can collect the database from different remote devices. So this is how the automation work, and this was the main application. But out of these three, we have to only focus upon two applications. The one is software home appliances, and the second one is hardwired automation office appliances. As we all know that we have to be here for next 6 weeks for this program. And as I'm mentioning again and again, this is the combo of hardware and software. So definitely somehow, somewhere, we will also be understanding about hardware. We will be understanding about hardware also. So it's not only about smart automation. It's not only about home automation, or it's not only about home automation or building automation, sorry. It's about agriculture, healthcare, medical, irrigation. So we have a lot of fields available where we can work with IoT and embedded systems. So now we understood the main concept and topic which we are going to cover for the next 4 weeks. And for remaining 2 weeks, we have to work upon projects as well as the IoT part. So IoT, many times I have visited almost all the institutions and universities of Uttarakhand, and few universities in south area as well. Even recently, I was in VIT Vellore. So what I have observed, a lot of people think that the IoT is new technology. But IoT is not new. IoT is very old technology. It's just the name is new. IoT, the word is new, but the technology is very old. How? Let me tell you. IoT mean Internet of Things. Like everyone knows about it. But what exactly? Let's understand. Things mean embedded system. Things mean electronic devices. So we may have a lot of electronic devices like sensors, actuators, like inputs, outputs, like relays, contractors, relays, actuators, transducers, pumps, valves. We may have a lot of electronic devices. Now, when we start connecting those devices over the network protocol, what I said, when we start connecting those devices over the network protocol, it is called IoT, Internet of Things. So as I said, this is not new, right? Everyone use internet on daily basis. Even right now we are using internet. That's why we are able to join this meet. So what exactly we have to do? We have to interact. We have to interface with those devices. We have to establish a communication between the cloud and the device. So I'll not take much time today, and because I have to tell you the outline of this program as well, what exactly we are going to do for the next 6 weeks program. So I'll take one example, and we will try to understand what is actually IoT and what is the need of embedded, and then we will go further for the outline of the program. Suppose you have to make your home automation. So everyone has LED bulbs, or we may have LED tube lights, many things we may have at our homes, right? And now suppose we want to include automation in this. When I'm entering to room, when I'm entering to my room, I want the lights to turn on automatically. And when I'm going out from the room, I want those lines to turn off automatically. So what exactly we have to do for this? We have to put a proximity sensor on the door. Suppose this is my door. So here we have to put the proximity sensor. If someone cross by, the sensor will sense and give the feedback to the controller. Controller mean the hardware of embedded system. And according to user program, we all are the users. We all are the users, right? And we will be creating a program. Whenever sensor give a logic 1, turn on the lights, and whenever sensor give the logic 0, turn off the lights. We all know about logic 1 and 0. In binary systems, the 1 and 0 represents true and false, high and low, on and off respectively. So this program we created, sensor gave us the logic 1, the lights goes on, light goes turned on automatically, and if sensor giving us 0, the light goes off automatically. This was smart work which we did. Now, suppose I am into the room, the lights are on, and I want to sleep. I have to sleep. So obviously, if I have to sleep, I want lights to off. And this is not going to possible until I go out from the room, because we have programmed it in a way, if someone goes outside, then the light should be off. Now we have to include the manual process as well. So what we are doing, we already have on-off switches at a house. So we are including them as well, the sensor and the switches. Both are working simultaneously with the embedded system. So whenever you come inside, the sensor is sensing, lights goes on, and whenever you're using the switches to turn it on or turn it off, it's working simultaneously. Done. Now let's make it more advanced. Suppose there is switch, I want to turn it off. It's around 3 meters from my bed. I'm looking at that side so that you can understand. You have to imagine, okay? So my switchboard is around 3 meters from my bed, and I have to turn my lights off, and I'm very lazy person. I don't want to go there. I want to keep it off in this way only. And now it's not possible for me to keep it off from 3 meters of distance because my hand is not so long. Now, what we can do, we have a lot of devices like GSM module, Bluetooth, Wi-Fi, Zigbee modules. These are basically wireless devices. So what I want, I'll be controlling that switch using my mobile phone. If we have something like we can send the logic from here, we can keep it on and off. So GSM module is like basically working upon your messages. So you have to simply type a message from your phone to turn it on or to turn it off. As soon as the message is going to deliver to that switch, where exactly we have that controller, which is controlling the whole process, it will turn on or turn off a light. But as I said, as I mentioned, and again mentioning that we guys are so lazy and we don't want to work so much. So now the things are like, I don't even want to type too much. Now what to do? And also like it's not mandatory to type turn on, turn off in the message. We can simply write on, off, or we can simply write 1, 0. But the point is, when this technology started, that time message cost was too much. Now we know that it's free of cost, but that time it was too much, around 1 or 2 rupees per message. And suppose if we have to keep it on and off 100 times in a day, we have to spend around 100 rupees per day just to turn on and turn off the light of one single room. So this was expensive. That's why we started using Bluetooth module. We connected one Bluetooth over that switchboard. where exactly we have the controller, which is controlling the whole process. And we already have Bluetooth inbuilt in our phone. We just have to establish a connection. We just have to establish a communication between these two Bluetooths so that they can understand the language of each other. And we are transmitting those signals from either iOS or web application or Android applications. So we can create Android application or web application or iOS application in our phone and then sending those logics over the Bluetooth protocol. But we have a limitation here. It can only work till the range of 10 meters. That's fine. The problem is solved. I have to turn on or turn off the lights inside my room, and this uh, range of 10 meter is enough because 10 meter is too much for the size of a single room. But suppose if you are somewhere outside and you forgot to turn off the lights of your room, and whenever you're going outside, you just thinking, oh shit, I forgot to turn off the light. And now you are around 1 or 2 kilometers. So that time, Bluetooth technology is not going to work. That time we can use Wi-Fi modules. Although we know that the Wi-Fi has the range of only 100 meters. But if we start using industrial Wi-Fi, then that time we can get the range of around 900 meters to 1000 meters, but just 1 kilometers, right? And suppose if we are into the range of 2 or 2.5 kilometer, that time we have LoRa devices for IoT. LoRa devices, we can use them. These also works on wireless communication. And the frequency bandwidth is 2.4 gigahertz. Now, if we are after the range of 2.4 kilometers, we need to establish the connection with multiple LoRa modules, LoRa 1, sending the packets to LoRa 2, sending the packets to LoRa 3, to LoRa 4, and then main device. So this is going to be very expensive. Then finally, we have IoT. Where we can connect those devices over the network protocol, network layers. That means you have to transmit the data from your Android to cloud, and cloud has to transmit that data to the device. So you don't have a range. We all are Indians here, and most of the time we use the servers of US for this cloud communication. So what exactly we do, suppose you are making a simple project of building automation, smart building or smart home. First, you will create the Android application. You will install that in your phone. You will transmit your data to the cloud. That means you are sending your data to US, and then US cloud is sending or transmitting that data back to your device. So that means Android to US cloud to Indian device. And if suppose device is also replying, so device, Indian device to cloud US to your Android phone. So this is two-way communication where we can monitor and control the data. So this is called Internet of Things. That's why I mentioned Internet of Things is not very new. We just have to establish the communication between embedded systems and the network protocol. So throughout this journey, I'm very quickly telling you the outline. For the first 4 weeks, we are going through embedded systems, where we will deeply study about AVR controllers, especially for robotics, and Arduino controllers, especially for IoT. Then the next module is to work upon simple projects based on individual topics and major projects based on all the topics, combining them. Once we complete these things by the end of almost 4.5 weeks, we will be starting Android application development. We are here going to learn how to create Android applications as well. Once we're done with this part, then we will be understanding how we can manage the database. So database management system we have to study. And at last, we will merge all these things together. For IoT, embedded, Android, and cloud. Embedded, Android, and database. So we will combine, interface each other so that we can start monitoring and we can start controlling the devices or the data or the logics or the signals. So that's how we are going to complete this 6 weeks internship. So that's it for the day. We will go Monday to Friday, correct? We will go Monday to Friday and same time 10 to 10:40. So I request you all to please join by the time, because if we waste 5 minutes on daily basis, we will be lagging with one class. Okay. So we have to join it regularly. And I hope each and everyone has the software package. You have to just extract and install the softwares. The video to installation is already being shared with you guys. If you have any problem, you not need to worry about, just keep the softwares ready with you. I'll tell you each and every step how to install. If you are facing any errors or something related to that, I'll let you know. No worries about that. That's it from my side for the day. Thank you so much. Now I'll be taking your doubts. If you have any questions, you can ask me.
Hello,
Anyone?
sir.
Yes, please.
Yes. Yeah, you have said that you are going to use Arduino board, controller board, right?
Venkatesh, your voice was not clear
Uh,
in between.
am I clear, sir?
Yes, yes, please go ahead.
You said that you are going to use Arduino board, right?
Yeah.
So if I want to purchase a board, controller board, what board should I go to purchase?
See, in Arduino, we have a lot of boards: Arduino Uno, Arduino Mega, Arduino Mini, Arduino Pro Mini. So you not need to purchase any boards for now. At least be with me for next week, for 1 week, and then you will be choosing those boards by yourself. Okay.
Okay, if I have already STM32 nuclear boards, so actually,
STM32 nuclear board is something different. But yes, we can use that also. There is no problem.
okay, sir.
Yeah.
So actually, I have completed internship in 6 months in startup company. So I
Okay.
have basic knowledge.
With
So
STM32 nuclear.
STM32 and ARM controllers like SAM E51, SAM
Mm,
E54.
got
In
it,
the
got it,
startup
got it.
company, they are using. Yes.
So why don't you work
So
upon EVLs as well? Because those controllers are mostly used in electric vehicle design. I'll interrupt you for a minute. Actually, the session is about to end in a minute. So you can rejoin the session after 10 minutes if anyone has any doubts. Okay. Yes, please continue.
yeah, I have already taking internship in a startup company.